My name is Shakthi. I am working as an assistant professor in the CSE department from Hindusthan College of Engineering and Technology. Today I am going to explain the basic concepts of a graph and also explain about the Kruskal's algorithm. Contents I am going to deliver in this lecture is definition of a graph, types of a graph, weighted and versus unweighted graph, applications of graph, then I will explain minimum spanning tree, then I will explain and solve a problem using Kruskal algorithm. Definition: a graph G consists of two sets. Graph is a collection of vertices and edges. In this diagrammatic representation, the vertex are 0, 1, 2, 3 and 4. The line which is connected the vertices is called edges. Types of graph. Basically, the graph is divided into two types. One is directed graph, next one is undirected graph. In the directed graph, the vertices uses the direction to the particular edge. That is here in this diagrammatic representation 1, 2, 3 or 3 vertices. In this undirected graph, the edges, there is no direction in the edges. That is, the path between the 1 to 2 also possible, the vice versa also possible in this undirected graph. Whereas directed graph, the path between the 2 to 1 is possible, the vice versa is not possible. This is the difference between the directed graph and undirected graph. The possible vertices in the undirected graph is 1, 2, 3 and the set of edges 1 to 2, 2 to 3, 3 to 1. In this directed graph, the set of vertices are 1, 2, 3. The edges are 2 to 1, 1 to 3 and 3 to 2. Weighted graph versus unweighted graph. The difference between the weighted graph and the unweighted graph is we have to mention the cost or weight in the edges. This is the example of weighted graph. Here 1 to 2. This is the edge 1 to 2 is connecting the vertices 1 and 2. The weight is 2. Next one is 1 to 4. This is the path. The edge weight is 1. 1 to 3. The edge weight is 3. 2 to 4. The edge weight is 4. 4 to 3. The edge weight is 5. Okay, this is a weighted graph. We have to mention the weight in the edge. Here there is unweighted graph. There is no weight in this graph. Next one is we are going to discuss about various applications of graph. There are n number of applications of the graph. The graph is applied in all the fields. For example, it is used in chemistry, physics, computer science, biology, electronics, and operation research. Here, mainly in the computer science and engineering field, it is used in data structures, operating system, computer networking, data mining, networking system, artificial intelligence, image processing. These are all n number of applications of graph. Next one is minimum spanning tree. The definition of minimum spanning tree is a subgraph of an undirected graph such that the subgraph includes all nodes, is connected, and is this minimum spanning tree is a acyclic graph which contains only minimum number of weights. All the vertices are connected with minimum weighted edges. For example, in this graph you are having 1, 2, 3, 4 vertices. Then number of edges are 1, 2, 3, 4. Okay, 4 edges. Suppose you are having 4 vertices, we have to connect all the vertices with n minus 1 edges. For example, n is a number of vertices, then n vertices can be connected with n minus 1 edges. See here we are going to calculate the minimum weighted graph. This is one way. We have to connect A to B and A to D and C to D. The weight is 6. Like that we are going to connect A to B, A to C and C to D. The weight of this subgraph is 9. Then A to B, A to D and A to C. The minimum weight of this subgraph is 8. Then we have to compare all the possible subgraphs and we have to compare all the weights. We have to choose the minimum spanning tree which contains the less weight. That is, we are going to select less weighted subgraph as a minimum spanning tree. Next, we are going to discuss about the Kruskal algorithm. Kruskal algorithm is used to find the minimum spanning tree for connected weighted graph. In this Kruskal algorithm, we apply or follow two steps. One is we have to sort all the edges by increasing edge weight. Next, we are going to select n minus 1, that is total number of vertices minus 1 edges, and also the minimum spanning tree is a acyclic graph. Acyclic graph, that is, do not generate a cycle. Just you have to consider this graph which contains 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices and connected with a number of edges. It is a weighted graph. Next, we are going to find the minimum weight. We have to tabulate all the edges weight in the ascending order. See here, this is the edges. 1, 2, see here. Next one is distance. We have to find the distance 1, that is D to E. See here, D to E. See here, the D to E. Distance is 1. Next one is D to G. Distance is 2. This we have to select this edge first, D to E. Next one is we have to choose the edge D to G, 2. Next we are going to select the next weighted edge is 3. That is E to G. Suppose we are going to connect or choose this edge, then there is a cyclic. It forms a cyclic, that is D, E, G, again D. That's why we don't select this edge. Next one is we have to choose D to C. Next one is we are going to choose G to H. Next we are going to choose C to F. Next we are going to choose the edge B to C. Next we are searching the next edge B to E. Then we are not choose this edge because it forms a cyclic. Next B to F, we are not choose this edge also because it creates a cycle. Next one is B to H, it also is a cycle. Next one is we have to connect A to H, there is no cyclic form. We have to choose this A to H. Okay. Because these almost we connect all the uh, vertices with 1, 2, 3, 4, 5, 6, 7 edges. That is 1, 2, 3, 4, 5, 6, 7 edges. Then we have to find the cost of this subgraph, acyclic subgraph is 21. Okay, this is the final minimum weighted graph after apply this Kruskal algorithm. These are all some of the references. Thank you.